Okay, this trick is called the popping magnet. Unfortunately, when I unpacked this device today, I found that one of my magnets was broken, but it still works. This is a neodymium iron boron magnet. It's magnetized vertically, so the north pole is on the top and the south pole is on the bottom. This little magnet, which was broken, also now has the north pole on the top and the south pole on the bottom, so of course it sticks. Now, surprisingly, if you turn it over, it still sticks. What the heck is going on here? Well, if I move it to the edge, that's why it's called a popping magnet. Okay, let's do that again. It's stationary, north pole to north pole, stable. If I move it with my thumb to the edge, it pops right off. Okay, what's happening is that when the north pole is in contact with the south pole, of course, it's stable. When the north pole is in contact with the north pole, it's not so stable, but it's marginally stable. When I move it to the edge, there, the force is larger and it pops off. What's happening is shown over here in this graph. A friend of mine named Vince Kelly did a very nice finite element computer model of the magnetization in the large rectangular magnet. Blue means north pole and red means south pole. What that means is that this top magnet, the little magnet, which used to be rectangular, is actually magnetizing the big magnet in the other direction, which is why it's stable in that configuration. That magnetization of the big magnet in the other direction is, however, only temporary. And when the little magnet is removed, the big magnet recovers right back where it was. When you move it to the edge, the force between the little magnet and the big magnet is much bigger. It isn't stable anymore, and it pops off.